What is electricity's resistance? Have you ever wondered why some materials allow electricity to flow easily while others resist it? Today, we will uncover the concept of electricity's resistance and its role in our daily lives. Electricity's resistance is a measure of how much a material opposes the flow of electric current. Imagine trying to push a heavy object across a rough surface. The roughness makes it harder to move, just like resistance makes it difficult for electrons to travel through a conductor. The greater the resistance, the less current flows when a voltage is applied. Resistance is measured in units called ohms, represented by the Greek letter omega. This relationship is defined by Ohm's law, which states that resistance equals voltage divided by current. If you have a higher voltage but the same current, resistance will increase. Several factors influence how much resistance a material has. First, the type of material matters. Conductors like silver, copper, and gold have low resistance because their atomic structure allows electrons to move freely. On the other hand, insulators like rubber, glass, and plastic have high resistance, preventing electron flow. Next, consider the length of the conductor. Longer conductors have more resistance because electrons face more opposition as they travel. If you think about a long water hose, the water flows slower at the end than at the start. The cross-sectional area also plays a role. A thicker conductor has less resistance because it provides more pathways for electrons to flow. Picture a wide road versus a narrow one. More cars can travel on the wider road at the same time. Temperature is another factor. For most materials, resistance increases as temperature rises. This happens because the atoms vibrate more, making it harder for electrons to pass through. Resistance is closely related to a property called resistivity, which is the resistance per unit length and area. This property is intrinsic to the material itself and helps explain why some materials conduct electricity better than others. In everyday life, resistance is why electrical devices heat up when current flows through them. This heat is a result of resistance converting some electrical energy into heat energy. It also affects how much current flows in circuits, which is crucial for the design and safety of electrical systems. For instance, wires are selected based on their thickness and material to keep resistance low and prevent overheating. Understanding resistance helps us grasp why some materials conduct electricity easily while others do not. It connects the behavior of tiny electrons to the practical realities of technology and nature. So, the next time you flip a switch or plug in a device, remember the fascinating role of resistance in making it all possible.